computer. So last question, what is this called? This is a Akai Iwi Solo. There are multiple versions of the Iwi. This is Iwi stands for EWI. It is an electronic wind instrument. That is what Iwi stands for. These aren't buttons, they're touch sensors, and it's just simply set up like any clarinet or saxophone. So it is an interesting instrument, especially coming from and again, I'm coming from this as not only just a brass player, but a horn player who, and for those of you who don't know, the reason the horn instrument is considered a bit difficult is because you control a lot of stuff with your lips, with your embouchure. You don't move, you can get away with not having to move your hands so much. Whereas, and I like that because I'm terrible at moving my fingers. Whereas this thing, move your fingers all the time. No, I am not going to play right now. I'm not going to embarrass myself and be very hard to hear. Maybe in a few other lectures. I'll be happy to show you some other music that I do later though. Zoom concert might be fun. Speaking of Zoom, tonight on Discord. First off, we do have a Discord channel, link to the front to it on the front page of Canvas. You should totally join. Tonight at 7:30, I will be hosting Jackbox Games on the Discord server. So the players of the game will be first come, first serve, but don't let that stop you, because guess what? If you join, the game is made for our audience participation, meaning the audience can play the game just as well as any of the players. It's really fun. I'm doing it at 7:30. I'll go for at least an hour. It's just a way to keep everybody's morale up. Okay. And also to have some fun. My only request is that we keep it PG-13, since as a Temple University professor, I have set this up. So technically, I guess it's not so much Temple sponsored as like affiliated. So keep it PG-13. And I do get to put on my, and part of the reason I can kind of do this is because also I'm the club. I'm faculty advisor to two clubs. I'm faculty advisor for TU Dev, which is the hackathon based kind of workshop based coding group we have here, as well as the Temple University Gaming Guild or Gamers Guild, which is as you might expect, all about games. I mean, yes, but it's all about the appearance of decorum, you know? All right, so with that, let's go ahead and get started. So for today's exercise, and yes, this is part of the reason I waited a couple minutes. What we're going to need to do is you will need to log into Runestone for today's exercise. So let me go ahead and share my screen. So for those of you who haven't, I want you to go ahead and go to runestone.academy, right? And I will just drop that in chat for everybody. Okay. And what you'll want to do is you'll want to log in, and if you haven't registered for it yet, register for the textbook using the codes, using the course name Spring 2022 Rosen. Now remember, when signing up, I want you to, one of the two things need to be true. You either use your TU letter number, you know, at temple.edu email address as your email, or your name on Canvas has, or the name that you have on Canvas has to match the name that you plug in as your name. I rely on one of those two things matching to migrate the grades over. Does that make sense to everybody? That's how I can tell you apart. Now I also did get some questions about, hey, I did some of the assignments on Runestone, by the way. It got as like, it says, I did these exercises. I did exercises 1 and 2, but it says I haven't started them. That's only that way because in order for me to grade assignments on Runestone, I have to run the auto grader. It's which basically the grade you see on your assignments on Runestone, like if we go to chapter 1 exercises, these self grades, that's exactly what it is. It's basically saying, hey, if I ran the auto grader, this is the grade you would get. Make sense? You only actually get that grade once I run the grader. Okay. The course name is Spring 2022 Rosen. So I just want you to take a few minutes to log in if you or to create an account if you haven't. That way you can get credit for what you're actually doing and you don't have to redo it later. So another thing is that you may read the chapter and then you get to chapter 1.12. This is one of the only silly things in the textbook. Oh, did they fix it? Which is under contributed exercises. Yes, they fixed it. Great, I think. They used to have like way too many assignments under this contributed exercises, and they would all freak the students out because basically that was the default place to put new questions, and people would write questions for whatever part of the book, and they'd end up in that section of the book. You don't want to be in Spring 2021, Rosen. If you haven't, yes, it's okay if you've scored them, but you need to be on Spring 2022, Rosen. If you need to, what you should do is that if you're logged into a different course, click the change course and hit this button, enroll in a course, and just simply type in the course name here, Spring 2022 Rosen. Or if the course is already here in this list, select it. Make sense to everybody? Okay, so you want to select this one, Spring 2022 Rosen. So what I like about this textbook is that it doesn't require you having Python installed on your computer or whatever device that you're using. And for the most part, I do grade these. These will be graded primarily on participation, as opposed to correctness. So the other thing I love about this textbook, if I zoom in, scroll all the way down to the bottom, and we've got this lovely project list. So today we're going to be looking at project 1, a preview of the end goal. This is what we were linked to from Canvas, if you've checked your Canvas links, but that's okay. So we just simply click on this link over here, a preview of the end goal, and I will go ahead and drop this in chat for everybody. And what we've got here is just basically, it's going to be a demonstration of all the kind of things that this of what you should learn in this course, as well as this textbook. The idea here is that coding is awesome, but it's intimidating. But people often look. It's got a great example. Like any other skill, you have to walk before you run. You would not expect to sit down at a piano for the first time and play Beethoven's Piano Sonata number 32. You have to work up to that with a lot of practice, and it's no different than writing code. And for some reason, people think when people see other people doing code and basically being quote unquote unnatural at it, their first thought is, I'm stupid, I don't belong here. And it's not, oh, that person must have had a head start in practicing. Right? Or this person practiced more than me, So the idea of this entire big project is to give you an idea of all the things we're going to be able to do. For many of you reading this or taking a first course in computer science, that there will be many unfamiliar aspects to writing code. This text editor, it's actually, they say it's primitive, but honestly, it's pretty awesome. And what we're going to be working with is basically, we are working with what's called the Python interpreter. That's what you install on your computer when you install Python. You install the interpreter. That's a little program that translates commands that resemble English like this into the ones and zeros that a computer can understand. The important thing to remember about the interpreter is that they are evil genies. Okay? They are, or if you're familiar, or if you're more in the lines of urban fantasy, they're like the fairies. They do exactly what you bargained for. They don't have any intelligence. They don't do what you mean. They do exactly what you told them. So keep that in mind. So for instance, here's our first program. This is what a full program looks like. And there's words we understand in there. There's import and there's image. in this context here, what that means is that we are importing a package called image. And I'll get into that in a second, but we can just see that there's a lot of code here. There's some math symbols. Well, let's go ahead and hit the save and run and do this on your computer as well. And what it does is that it runs. And this is part of the reason I love this textbook, is that it is able to do things like this. So this is running something called process 11. So this is something we'll learn later, but this command is called def, which stands for define. One of the wonderful things about programming languages is that you can add to the language. There are nouns and verbs and adjectives in any language, and programming languages are no different. Here, what define does is that it creates a completely new verb. It says, hey, I have a verb. I want to make a new verb. The verb is called process 11. And when I do this verb, I do all these things. Formally, this is called a function, like a mathematical function. But it may help to think of it as creating a new verb for the language to do. And it does a bunch of things in here. It says, hey, I want to get the width of the image. So I take in an image. I want to get a width of the image, the height of the image. And then for every column and every row, I'm going to get a pixel. What in the world's a pixel? Any takers on what a pixel is?
RGB, it's like red, green, and blue.
Mm-hmm. Yes. Next one. Next. Anyone? I heard somebody else going to talk.
Yeah, I was gonna say it was like the small, basically like the small, tiny blocks that make up a whole image.
That's right. Yeah. Those are both correct things, right? If you get really close to your computer, I mean like uncomfortably close to your computer, right? And if you're using one of those new modern Macs, this may not be maybe an impossible task, because boy, did they pack those pixels densely. But if you zoom, if you look at your really close, really close, you'll see that all that image on your computer screen is actually made up of tiny squares. Those individual squares are pixels, picture elements. So, and what they are is that they're little lights. And they are composed of basically, and each of those tiny little squares has 3 lights in them. One of them emits red, one of them emits green, and one of them emits blue, as at a different level of intensity. Okay. So, by basically saying, so just like a painter saying, how much paint am I adding? This one says, how much light am I adding? And it says, let me do this much red, this much green, and this much blue. And that's how you get a picture. And your computer, again, does this all automatically. Automagically might be a better term for it, multiple times a second. If you're doing it on a, and if you're on most laptops, it runs at 60 hertz, which means it will be redrawing that 60 times a second. So what did this code do? We started out with a color image, but this turned it black and white. And what this does, and that's what this code did. It figured out, hey, let me get the pixel, let me get the red, blue, and green. If it's on average a darker color, we're going to make it dark. And if it otherwise, it's going to be white. So, well, sorry, you got that reversed. If the average value of red, green, and blue is more than 127, if it had a lot of light, it'll make it white. And then otherwise, it will be a black pixel. So it just simply colored everything white or black. So over here, so that's one of the fun things you can do. You can manipulate images with code. And that's what we're going to kind of start focusing on doing today, even though we can't program a lick of code. And this is kind of showing you that you don't necessarily have to understand everything about code in order to use it. Okay. Here in this block, we've got a bunch of codes, a bunch of code rather. We have we have this image, we have process 1, 2, 3, 4, all this stuff in here. And you could read through it, but honestly, that's a pain. especially since again, this is all new. And we've got these two pictures here, the Luther Bell pic.jpg and the yawning squirrel.jpg. Those .jpg and the .jpg on the end is important, by the way. So the idea here is that we can experiment. Our task is that is a matching task. We've got 10 unnamed processes, and we want to match these up with what they do. So it's a drag and drop kind of thing, like that. Now, the order that you got may be different than the order I got. In fact, I think that's part of the features of this. But here, how do we figure that out? Well, by running it. So in activity 3 over here, sorry, in this activity, we've got a code block that we can start modifying. And all these are modifiable. I run this and it says, hey, let me get this image, yawning squirrel, original. Then I want to do process 10 on the original image, which was yawning squirrel. I could change this to Luther Bell pic right over here, save it and run it. And we're only able to use these two pictures because they're what's loaded in, right? Does that make sense? You can't just call random picture on your desktop because there was a lot of work in the background to make sure that your web browser knew that these existed. So here, original image is equal to Luther Bell pic, and this is the result of doing process 10 on it. Okay, so what you can do is that you can change which picture you're working on, right? Just by going, hey, let me change the name. This one was called yawning squirrel. I can either type this in, yawning squirrel underscore, that's the dash, but hold shift down and you get the underscore. That's often in computer science, we often use because variable names need to be one word long, we often use underscore for a space, if that makes sense, to make sure that we know that we're talking about the same thing rather than yawning and squirrel being two different things. So here I could type it as yawning squirrel, but I could either be lazy or careful because I don't want to make any typos. I can copy that and just paste it in. And you'll want to paste it in this over here. And now what we see is that process 10 makes the squirrel look quite demonic and threatening. So my other thing is, notice that process 10 is a verb, and it takes in a parameter is what we do it. We feed it a original. Some of these functions over here, process 6 and process 5, they need some additional parameters. Like process 6, if I do, it says it needs two numbers, number 1 and number 2. They can be whatever you want, but you'll want to try it, but you'll need that to test it out. And here, there. So you'll want to figure out what those are by switching up what the process is. You're always going to want to feed it the original picture. And if you lose your place or you mess it up horribly, like that, and you try to run it, right? It says, that's not code. Yep, this is all pre-programmed by the textbook. They're like, this is not code. You've got an error, bad input. Guess what? You got a history function right here. Every time you hit run on it, it saves it. And you can go all the way back to the original. So even if you mess it up, that's fine. So does everybody kind of understand the exercise right now? Yep. I know for those of you who totally get this, you're like, yeah, let's go. I just want to make sure that everybody kind of feels comfortable with this and understands what the objective is. Because what I'm going to do now is that I'm going to stop sharing because that's easier. And I'm going to split you up into breakout rooms because that's generally the easiest way to deal with this. And I will go ahead and let's see. I'm going to create, there's 100 and you know what? I'm going to say let's make 21 breakout rooms because that's what I felt. That's what feels like fun. So I'm going to create 21 breakout rooms. Go ahead and launch yourself into any breakout room you want and get to work on it. Feel free to share your screen with the other people in the breakout room, the other students. Feel free to coordinate and collaborate and share answers with each other and explain answers to each other. Okay. And here's what's going to happen. Once we're done, I'll bring us back here and we can go over the answers together to make sure everybody gets it. Okay. So I'm going to open up all the rooms because I had forgotten to do that. And I will see you back in maybe 10 minutes. And if you have any questions about this, just send me a DM.
Do we just join a random breakout room?
Yep. Or if you've got one with friends in it, you join that one. Yep. Just join anyone you want. Does anybody here have any questions since you're still hanging around in the main area?
I just wanted to get the link from the chat. I'm about to go back to the breakout room.
No worries. I'm just staying behind to just ask if anybody needs any help. Hey, Daniel, do you need help?
Nope, I just did it by accident.
No worries. So does anybody need help in this room?
No, I don't think so.
I'm good.
I'm good.
Cool. This one just had a bunch of people, so I figured.
I do.
Okay,
Yeah,
sure.
I do. Okay, so I'm using a.
Resume the recording. Let's just wait for everybody to pop back in. All right. Students are coming back. Oh, cool. I didn't realize they changed the amount of seconds for the countdown timer. Nice. Well, that's done. Now I don't have to wait a full minute for everybody to get back. That's good. All right. So so let's see. I'm going to go ahead and share screen, preview the end goal. Okay, so let's go figure out what all these things did. Okay, so right, process 10, go ahead and run it. And it made the squirrel demonic. So not sure what that is. Maybe it looks like this one, it converts it to only black, white, red, green, and blue, especially based on when I ran it on the Luther Bell picture. Right? And I bet you, this is just my hypothesis of what it's doing, is that it's saying, hey, of the following colors, red, green, blue, black, or white, which is the color closest to? Make it that color. That's what I'm going to guess for that one. Okay, so let's start off with process 1 now. So we'll just go ahead and do process 1. Process 1 kind of makes it darker. Yeah, darkens the corner specifically. That's what it did, right? Darkened the corners of the original image up there. So I'm going to go with vignette effect. Process 2. And by the way, I haven't run these since last semester, so my memory is only so good. So this is how I would do it if I was there. So adds the Clarendon type effect. Darker's dark and lighter's light. Well, this part certainly got darker. So yeah. And then, but I find the yawning squirrel to be more amusing. So let's go ahead and take him and put him in. Oh yeah, made those darks really dark and those lights really pop. So that is process 2. Process 3. Yeah, only thing I have to be worried about is process 5, where I'm sure some of you may have tripped. And that's okay if you tripped there. I didn't really give you much direction. So this made it completely gray. This is what we call grayscale as opposed to black and white. Where basically it has completely made this squirrel, it's drained out all the color. So what happened there is that it averaged out the amount of red, the amount of green, and the amount of blue. That average means that it appears gray, lighter gray or darker gray, depending on what the average of the colors were. That flipped it. That flipped it 90 degrees. Now we need to take this and a number. Process 5 and a number. And this is okay if you trip there. So notice it says, hey, this takes comma a number. Just like how a mathematical function, like the really horrendous ones, like this one, f of x. Now that can also say, hey, it takes in f of x and y. Just like it can look like that and make you want to weep. Well, fortunately, programming doesn't really make you want to weep because we're not dealing with multi-dimensional kind of stuff like that. We are just simply dealing with pictures. But it's taking in the image, which has always been original for us, right? We can kind of see just going down the column, and a number. So I'm going to feed it a number. I'm going to feed it 2. And we'll go ahead and run it. And process takes 2 positional line argument, but 1 was given. So 1 position. I forgot to change it to 5. So you'll get errors and you'll get better. And once you start programming, you'll learn more about how they work. So 2. So let's experiment. If I give it 1, if I give it 3, and if I give it 4, and if I give it 4, I bet I'm going to get it all the way right side up. So process 5 rotates by multiples of 90 degrees. So every time I was rotating this by 90 degrees, okay, I guess I have to zoom out. Or zoom in rather. Zoom back in now. So every time so 1 made it rotate 90 degrees, 2 made it rotate 180, 3 made it 270, and 4 made it 360. Can I do any of those on a skateboard? No, I can't do any of those rotations because I can't do any skateboarding. That's not my thing. Okay, so 6. Here, the original is given. The process is given 2 numbers. So here I'm going to give it 2, and let's go with 1. See how basically it said, hey, you got this, now you got a number, another number. So I'm feeding it the appropriate arguments. And if we look back up here in the code, by the way, up to process 8, sorry, process 6, right? It says, hey, we need 3 things to be called, right? All these processes, they all require something. Most of them require just one thing. This one requires 3 things. That's just the way it works. So let's run this and let's see what happens. I think I did this, and it makes our squirrel a chunky boy right here. But again, with kind of experimentation here is kind of key. So if I up this to 3, let's see. And now we're getting more to the fact that it looks like rather than being well fed, he looks more like that he's been run over with by a steamroller at this point. So now let's go ahead and swap this to maybe 2 and 2. That's our original image right there. But 2 and 2 make it, let's see, bigger. So this one scale enlarges it in the X and Y direction. All right, process 7. And here we can remove these because, or we need to remove these because it only takes in 1 argument. Okay. Converts to high contrast, only black and white. That was 7. So now we just have 8 and 9. So that is a very interesting Leiden's image for 8. And, you know, I could check number 9, but honestly, feels a little silly at that point. Click, click, darkens. Check. Hey, I got them all right. Awesome. So that's what you wanted. So that's what you want to do. If you didn't get your answers, you could copy them down as I was going through them, or refer back to this lecture video once once class is over. By the way, where are things going to be uploaded for lecture videos? We go to Canvas, right? Go to Intro to Problem Solving in Python. And to find our lecture recordings, you just click here under lecture recordings in the middle. Okay. And here you go. This is a playlist to see a different additional videos. You just click here. If you're interested in getting a head start and checking out previous semesters, I've got a bunch of previous semesters back here. So feel free to check those out if you need to, but any recordings I do will end up in this playlist. And you can go directly to YouTube on this. I try not to monetize my channel, so your likes and subscribes mean nothing to me. That's not to say that's not me saying don't subscribe. It's just like I don't need them. I would feel highly unethical if I was monetizing the resource that my students used to study. That feels wrong. Do we need to? Excellent question. Yes, you need to turn in these. How do we do it? You turn them in by doing them. That's the wonderful thing about this. Here's what happens. Let me just kind of show you on the instructors page. Okay. And I'm going to stop recording for a second, just in case I need to turn off sharing because of any potential kind of Zoom recording. Yeah. And again, the reason I turned off that recording is I didn't want to accidentally have a FERPA violation. I didn't, but if I did, I certainly didn't want that to be on something that I would have to edit because editing takes time. It's annoying. All right. So now it's your turn to combine these various effects. That's another thing you can do. You can combine these effects. So notice over here with this last one, you can always pass a function into a new function, just like in math, in math, which looks kind of horrifying when we do it like this. You can totally do like g of, you can do g of x, but you can also do g of f of x, right? Already giving some of you nightmares, I know, but that's okay. Just like you can do that, you can totally chain these things together like this, except that's also horrible to read. So don't do it that way because it's just one blob of letters and parentheses. It looks ugly. Here instead, what they did over here was that they broke it up into steps. Here, let's take the yawning squirrel. That's our original image. Let's do process one on it, and that gives us a new picture. That's step one. Then we'll process that picture using part 4, and we'll get our final picture. So I could even add a step 2 is equal to process 10. And then here I would give it step 1, right? Because I wouldn't give it the original because step 2, I'd want to take step 1 and give it the step 2. And this will make a new variable called step 2. And then final would take in step 2. That's one way to do it. And let's run it. And then I'll run the original. Should have done that first. But here we did that's step 1. That's turning it demonic, and that's flipping it. So you can just call these multiple image manipulation things together. We're going back over here, right, to our original one. Here, we darken it and rotate it. There's also nothing stopping me from going like this. And here, and this will require some, you know what, I could do it like that, but I don't want to be too, I don't want to introduce too much too quickly. So I'll do that like this. Here, I'm going to chain it together, then keep applying the same effect to it, which makes it darker and darker. Yeah, if I kept darkening it, I don't think I'd be able to sleep. Be worried about that squirrel like standing over me, ready to ready to pounce. So you can do this. So have fun with that. Now, there is one thing I want to mention, which is this sign over here, the equal sign, which you know how that works. You know from mathematics, but I got to say that it is not what you think it is in computer science. In programming language, that equal sign means something different. Okay, it says the thing on the right, we're going to create the equal sign has an expression and a variable. We're going to take everything on the right and put it in the variable on the left. So it's easier to think about this as kind of an arrow, right? That is actually the mental model you should have when you see a single equal sign by that, which is that I am taking the process 1 output and putting it into the step 1 variable. And then I'm taking the process 4 out, the process 4 output and putting that in the final variable. We'll go into more about this when we see chapter 2, when we're talking about variables and assignments. Okay. But so if I'm saying it's better represented as an arrow, then why don't we use an arrow? And the answer is because you're already trained to read this differently. You're not trained to read that as an arrow. You're trained to read that as step 1 is less than negative process 1. So that doesn't really work. What if I did this? Well, now it's just less than or equal to, right? So some programming languages, because of that, they instead decided to use something called what we call lovingly the Walrus Operator. Because if you look at it like this, kind of looks like a little walrus, right? But and some programming languages like Google Go has that as a operator, and I do love it just simply because of the name. But we use the equal sign because it's close enough to what we mean. We're setting step 1 equal to the output. But really what we're doing is that we're taking this output and putting it in this variable over here. So here's what I want you to do with the remaining time in class. I want you to play around and try something and see if you can't create something new. Now this time I'm getting an error because step 3 over here doesn't exist. Step 1, gotta use step 1. Again, if you need to, you can back up like this and go back to your original code. Now, once you're done with this project, here's what I want you to do. I want you to complete this questionnaire at the bottom. I don't know if it populates it from stuff from last semester, but go ahead and fill out this questionnaire saying, hey, was I comfortable? Was I learning or was I panicking? How much time was it? And that kind of stuff. We'll be doing a lot of projects out of this textbook, and that questionnaire is very useful for me. What we'll be doing is in the future, or in the next couple lectures, that we'll learn about how to mess with graphics and that kind of stuff in a fairly straightforward way. And I know it's graphics, that's sounds like a big leap, but really with Python, it makes it fairly easy to do some basic stuff. But go ahead, play around with this. Then when you've done all the exercises, you can hit mark as completed. And what you want to do is you want to get make sure that all these are done. If they're not all showing up as done, you may have to go over to this one, which activity 2, and hit the save and run just simply so that it logged you interacting with that one, if you get what I mean. Okay.
I have a question.
Yes.
So you know how in the textbook, when the assignment chapter 1 readings, it's only like 1.1 through 1.9, but chapter 1 is all the way to like 1.12. So
yes. So let me check the table of contents. What did I leave out? So yes, because those are comments, glossary, and those are really only useful as a reference if you need them. And
Okay.
then typically the assignment page, the page where we list assignments, they generally have more assignments than we actually need,
I see.
So
Right. Yeah, I remember you talking about the contributed exercises having like everything.
So yeah, I just want you to read those. And again, if you haven't checked out how the assignments work, the links on the, so first off, going to Canvas, now that you've all signed up on this, going to on the overview page where I talk about your assignments, clicking on a link to the assignment will bring you over here. Make sense? It'll bring you over to this page, which can also be accessed by going to this little person outline over here and clicking on assignments. And that will give you a list of all the due dates from the latest at the top to the soonest at the bottom. To do the assignments, right? Essentially, you can go through it, read the page, mark it as completed. You will typically need to interact with everything in the page, right? There were 3 activities here. Did you interact with them? Well, I'll go ahead and mark it as completed anyway. Then I can go back and say, score me, and it will tell you how much have you done. This will tell you when I run the grader, what grade will you get? After I run the grader, this score me and mark in progress, it will disappear. Don't worry about it when it disappears. That just means I've ran the grader. Okay, when I run the grader again, it will pick up any work that you didn't do the first time, but have done the second time. Okay, so again, there is no worries if you fall behind on the textbook reading. Try to catch up. Don't worry about it being late. These deadlines are there not as hard due dates, but as please complete it by this date so that you are ready for class and ready for the assignments. Does that make sense? And the points are there as incentives because, hey, 10% of your score for free is 10% of your score for free. Well, it's 5% here and 5% for doing the in-class exercises. Of which this was one of. And again, if it feels like I give you too much work with this stuff, let me know. So go ahead and work on doing some image manipulation in your textbook. And if you have any additional questions, I'm here to ask. We're here to be asked. I will also send out an email tomorrow with an email tonight, since today is Thursday, right? Today is Thursday, so that means 4 of the sections have lab tomorrow. So I will send out a email detailing what you're supposed to go to. If Christopher, if you can wait till after class to do that, I will demo stuff. I will take demos after class. Okay. But anyway, one of our TAs is currently sick with COVID, so I will be I'll be covering his lab section instead. I will send out I'll send out the appropriate links. If you're in this section, click this link. If you're in this section, click this link. Okay. On our page, one source of confusion may be also that you figure out what section you are based on what you registered for. You know, what is the course name in whatever you registered for. I've contributed to a minor amount of this confusion by doing this 1051-001. So you might think I'm in section 1. And what happened is that I created a course from section 1, and then I imported all the students from all the sections into this. So I didn't have 6 different Canvas courses that I'd have to change every week or something. That would be very painful. So again, what you'll want to do is you'll want to go to TU Portal or wherever to figure out what section you belong to. It will have that listed. And then I'll send out an email tonight as to say, hey, section 6 goes to here, section 3 goes to here, section 7 goes to this link. Okay.
Professor Rosen, I have a question.
Yes.
So I'm having trouble like stacking the different processes. Do you mind showing it just one more time, like with the different steps? I think I'm getting my numbers mixed up.
Sure.
Thank
So
you.
here it was just simply process 1. And so what I did is that this output step 1, and then step 1 was put in a final. But if I want to have some intermediate steps between that, what I did is I typed step 2 is equal to process whatever, whatever it is, right? And then I fed it step 1 because I want it to work on step 1. Now, then after that, I modified this one because the final, I wanted to work with this output, right? So it makes sense to go 1, 2, final, right? Otherwise I would have had, but if I didn't change this, this would have been, whoops. Basically working on the same image and not actually making any changes. So here, right, I can modify it like that. There's the first alteration, the second alteration, and the third alteration. Or I can do this, which says darken it, make it demonic. And then, oh, see, but then it flipped it. But it flipped the original image. So it flipped my step 1 image, the darkened one, because I put step 1 here as opposed to step 2. 1, 2, and put that in as step 2. Demonic, and now flip the demonic. Yes.
Professor Rosen, I'm curious as to how you got to this page. I typed it in the search bar. Is there another way to get to it? I mean, as in just I'm signed into Runestone and everything. I just couldn't find that specific.
Yeah. Here. Does that link work for you?
1 second. Oh no, I finished it, but like I just can't find it without typing in the search bar. I'm not sure if I'm not navigating it correctly.
So once you're in the on the textbook page, you find it all the way down on the bottom.
Oh, okay. All right, thank you.
And then I also see another handout. I'll get that in a second. I have a message via text which says, hey, so are the small assignments, exercises we do in the class all to do with the textbook? Pretty much all of them will be textbook based. There's a couple of them starting at, once we introduce for loops, I have a couple of exercises I made myself and that you'll turn in via Canvas. But again, those are fairly straightforward. You interacted with like everything on the page, but still says 9 out of 10. Okay, let me see. Did you hit save and run on everything, including the first one and the second one? I'll love it. I see your hand up.
Hello, I just had a quick question about tomorrow. So going into tomorrow, all we're doing is installing Python, like the first lab is not due to the week after, correct?
Right. The entire point of the first lab is to make sure Python is installed on your computer and that you understand how to use it or how to like run the program so that you can do the lab 2. Does that make sense?
Okay.
Right.
Yeah, I just wanted to make sure.
Mm-hmm. Other questions?
Professor, so with the like process 5, for example, like how you have to put the original and then the comma and then, you know, a different number. So it would just be step 1, comma, and then the number as well?
Yeah, if we wanted to do it on step 5 or whatever, I would just simply do 5 and X, where X is whatever number you want to put in, right?
Yeah.
So like 3. Don't actually put in X because the computer is going to go, what's an X? You haven't told me what an X is. You know? If you're finished, oh yes, if you're finished, you're dismissed, by the way. This class can get dismissed early. So if you're done, feel free to leave. Oh, and there everybody goes.
Thank you.
Thanks, Professor.
Mm-hmm.
Have a great day.
Yep. You too.
Professor, I have a question. Every
Yes.
time I try to use step 5 to change something, it always comes up with an error, and I'm putting the number next to it as well for like the rotations. But every time I remove it, the process works. So I don't know